A summary review from previous lessons. The nature of the test. 3 types of hypotheses test. The rejection region is based always on the alternative statement. So when we're looking at a left tail test, that means that our alternative statement has a less than symbol. And then the area of rejection would be the shaded region under the curve to the left. So just as a review, our critical value is always based on our alpha, and alpha is the level of significance, which is the area under the curve. And we're testing a test statistic to see if it falls into that area under the curve. So the region of rejection would reject our null hypotheses. The right tail test means that our alternative statement has a greater than symbol in it, and that would be the shaded region to the right of our critical value. So you're testing to see if your test statistic falls in the shaded region. And if it falls in the shaded region, we would reject our null hypotheses. And then there's that two-tailed test, and the two-tailed test is based on the alternative statement, a not equal to, and if it fell into either one of the shaded regions, it would reject the null hypotheses. So this is a summary review of the nature of the test. The next type of testing for the hypotheses testing is the t-test for a mean. And we would use the t-test for a mean when our population standard deviation is unknown. So the t-test can be used when the population is normally distributed or the sample size is greater than or equal to 30. The test statistic is the sample mean. The standard test statistic will use the standardized test statistic T, uses this formula, and we would test the standardized test statistic against our critical value. Finding the critical value in a T distribution. A note here is that the critical value is sometimes symbolized with a T sub alpha or a T sub 0. So when we're working with the critical value, it's based on the level of significance, or alpha. So the first thing you're going to do is identify alpha, which is normally given in the problem. Then you want to identify your degree of freedom. The degree of freedom is your sample size minus 1. And then we're going to find the critical value either in our calculator or by looking it up in the table. So if your hypothesis test is a left tail test, it is the area is alpha. So your area is alpha, and you would look it up in the table. And if you look it up in the table, you'll see none of your t values are negative, so you will have to put the negative sign with the t value that you found. If you're going to use the TI-84 calculator, you're going to press second bars, your distribution menu, and you want to choose number 4, which is the inverse T, and you're going to put in the alpha for the area, and then the degree of freedom, and then press enter, and it will give you your critical value. A right tail test, the area will be 1 minus your alpha. So remember, when you need to find the critical value and its area shaded to the right, you always need to find the critical value based on the area shaded to the left. So you would have to do 1 minus alpha to find the correct t value. In your calculator, you can do the second Far's distribution and then put in 1 minus your alpha, the degree of freedom, and press enter, and it will give you your critical value. If you're looking at it up in the table, it will simply be the alpha, and it will be positive because the table has all positive values. And then if it's a two-tail test, you're going to have to take that area, which is your alpha, and divide it by 2. Whatever that area comes out to be, you can go into the calculator, find your t value, and you'll have both the negative and then positive t value. So you're going to have both negative and positive critical values when you have a two-tailed t-test. So your rejection region would be where your test statistic is either less than the critical value or your test statistic is either greater than your critical value. So a key note here is that T is represented the test statistic, and that is when you're using the formula to find your test statistic and not alpha. And then you're going to compare it with your critical value. So a key note here is that the test statistic will always be to the left of your inequality symbol, and your critical value will always be to the right. Because when you look at the picture of the curve, the critical value is at the tip of the shaded region. And you're testing to see if your test statistic falls into the shaded region. Because if it falls into the shaded region, then you would reject the null hypotheses. So let's start by finding the critical value for your t sub alpha. So when we have a left-tailed test and your given alpha is 0.05 and your sample size is 21, you can either use the calculator, you got your alpha, which is the 0.05, and you want your degree of freedom, which is 20, and then either you're going to use the calculator or your table. Now remember, if you're using the table, you have to add a negative sign to your t value that you find. In this particular case, your critical value would be a negative 1.725. And that region would be your test statistic would be less than that critical value of negative 1.75. If this is true, then you would reject the null hypotheses. This next example, we see that it's a two-tailed test. So the first thing you're going to do is identify your alpha and then your degree of freedom, and in this case would be 25, and then you have to take alpha and divide it by 2. In the table, it does say 2 tails, so you don't need to take alpha and divide it by 2. It automatically does that when you look up the value. But in the calculator, you would need to take alpha and divide it by 2 to get your critical value. So in this case, our critical value, the negative one, would be 1.708, and the positive is 1.708. So your rejected region would either be your test statistic is less than a negative 1.708 or greater than the positive 1.708. Pause and try. So you should have gotten a t value of 1.323 with a region of rejection. Because it's a right tail test, your test statistic would be greater than 1.323. If that's true, you would reject the null hypotheses. Pause and try. So you should have gotten these t critical values with this rejection region. So finding the standardized test statistic. So we're going to be using the TI 83, 84 calculators. And if you have an 84 or above, it will still use the same process here. So when we're finding the standardized test statistic t to compare to that critical value t sub alpha, it uses this formula. So in the formula, you note here we need our sample mean, we need our population mean, and the S represents our standard deviation for the sample, and we need our sample size for the square root of. So when we're looking at this example, we have a sample size of 10 items is chosen from a normal distribution population. with a sample mean of 13 and a sample standard deviation of 3.5. At a 0.05 level of significance, test the null that the population mean is at least 14. So in this case, we have the null and the alternative statement written. When you have your information, you're going to go to your stat button, choose test, and choose number 2, which is the t-test. So this is the menu that you will find. Always make sure when you're given the information that your stats are highlighted. So you want to go over to arrow to stat and hit enter, and it will highlight stats. Then you're going to find from the information in the problem your population mean, and the population mean will always be represented in your hypothesis statement. You're going to find your sample mean and your sample standard deviation and then the sample size. Make sure that you're choosing the right alternative statement. And in this case, it's the less than, so you want to make sure that the less than is highlighted. So you would arrow over and hit enter to highlight it. Then you arrow down to calculate, and you will find your t-test statistic. So in this case, our test statistic is a negative 0.9035, etc. And we will normally just go 3 decimal places. Also notice here that it gives you the p-value. So using the t-distribution for the mean when our population standard deviation is unknown. The steps you're going to take is you're first going to state your null and your alternative statement. Identify your level of significance alpha and identify that degree of freedom. Now remember, you're going to need alpha and the degree of freedom to find your critical value. So to find the critical value, you're going to either use the table or you're going to use your calculator. And it's what we did in the practiced examples. So please make sure that if you have a left tail test, if you're using the table, to add the negative to your t value. If you're using the calculator, it will come out negative. On the right tail test, if you're using your calculator, make sure you do 1 minus alpha in the calculator with the degree of freedom. And then the 2 tail test, if you're using your calculator, make sure you divide alpha by 2 for the area. Then you want to find that test statistic. So you're going to get the test statistic and compare it to the critical value. So that test statistic is what we just practiced. You're going to go to your stat button, arrow over to test, and then enter in all the information. And then you're going to get that rejection region based on your alternative statement. So if the statement is true when you test your test statistic to your critical value, then you're going to reject the null hypotheses. If it's false, you're going to fail to reject the null hypotheses. And then you're going to interpret your decision in the contents of the original claim. So remember, when you're stating your null and your alternative statement, you want to make sure that you have identified the claim, because at this point it's going to be very important. So remember the wording. If your null has the claim on it, you're going to use the word reject or rejection. So it's all based on whether you're rejecting the null or fail to reject the null. And then if the claim is on your alternative statement, you're going to use the word support in some format, whether you choose to support or there's not enough evidence to support. So let's do an example here. A used car dealer says that the mean price of a 2008 Honda CR-V is at least $20,500. You suspect that the claim is incorrect and find that a random sample of 14 similar vehicles have a mean price of 19,850 and a standard deviation of 1,084. Is there enough evidence to reject the dealer's claim at an alpha of 0.05? Assume that the population is normally distributed. So in this case, I want to start off by writing my hypothesis statement. And my hypothesis statement here, because we're basing our claim is at least 20,500, it is on the null hypotheses, the greater than or equal to, and then you would write the complement, which is less than, on the alternative. So now you're going to identify alpha, and in this case our alpha is 0.05, which is given. Now I need to find my critical value for the t distribution, so I'm going to find the degree of freedom, and the degree of freedom is the sample size minus 1. So in this case it would equal 13. And then I'm going to find that critical value. Either I'm going to use the table or I'm going to use our calculator. And it's always based on the alternative statement. So we have a less than symbol, which means I'm going to use the calculator and I'm going to put alpha in with the degree of freedom, and I'm going to find that t value. Or you can look it up in your table. So in this case, I find my critical value is a negative 1.771. So now I have the critical value, and now I'm going to need to find that test statistic. And to find the test statistic, we're going to use the calculator. You're going to go to your stat, arrow over to test, choose number 2, which is that t-test, and enter in all the information. Once you enter in the information, you should come up with a test statistic equal to a negative 2.244. So now you're going to do the testing based on the region of rejection. Because it is a left tail test, you're testing, is your test statistic less than your critical value? If it is, if that's a true statement, you're going to reject your null hypotheses. Otherwise, you're going to fail to reject. So I'm testing here, is a negative 2.244 less than a negative 1.771? And in this case, it's true. A negative 2.2244 is less than a negative 1.771. And because it's true, that means that I am going to reject the null hypotheses. So I'm rejecting the null. And because my claim is on the null hypotheses, there is enough evidence to reject the claim that the mean price of a 2-year-old sedan is at least $20,500. So when you have a claim on the null hypotheses, you're using the word reject. And in this case, because we came up with rejecting the null, we're also rejecting the claim. So this next example here, we have an industrial company claims that the mean pH level of the water in a nearby river is 6.8. You randomly select 19 water samples and measure the pH of each. The sample mean and the standard deviation are 6.7 and 0.24 respectively, which means the sample mean is the 6.7 and the standard deviation is 0.24. Is there enough evidence to reject the company's claim at a level significance of 0.05? Assume that the population is normally distributed. So the first thing we're going to do is write our statement. And our statement here is our claim is saying that our mean equals 6.8. That's where our claim is on our null hypotheses. And then the alternative is his complement, which means it does not equal 6.8. So I'm going to identify alpha, which is the 0.05 here, and the degree of freedom, which is 18. Now I have the information to find my critical value, and because it's a two-tailed test, if I was using the calculator, I would need to divide alpha by 2, and then find my critical value. If you're using the table, you would just go to the two-tail and look up based on the alpha of 0.05. So in this case, we're going to have two critical values, the negative 2.101 and the positive 2.101. Because it's a two-tail test, we have two critical values. Now we're going to find our test statistic by entering it into the calculator, and you're going to enter in all the information from the problem. So in this case, we ended up with a test statistic of a negative 1.816. So now our rejection region, or our test region of rejection, is either the negative test statistic is less than the critical value, or the test statistic is greater than the critical value. So I'm testing, because our test statistic is negative, I'm going to test it against the negative region. So when I do this, I see a negative 1.816 is not less than a negative 2.101. So that's false. It's a false statement, which means I fail to reject the null hypothesis. I fail to reject it because it's a false statement. And because I fail to reject and my claim is on the null hypothesis, so the decision in this case at a 0.05 level of significance, there is not enough evidence to reject the claim that the mean pH is 6.8. When the claim is on the null hypothesis, you're going to be using that word reject. If the claim is on the alternative, you'll be using the word support. Pause and try. So you should have come up with this statement and the claim. These are your critical values, your test statistic, and you see that the statement is false, which means you fail to reject the null hypotheses, and because the claim is on the null, there's not enough evidence to reject the claim. Pause and try. So you should have come up with this hypothesis statement, the critical value, your test statistic, and you see that this statement is false, and because it's false, you fail to reject the null hypotheses. And now the claim is on the alternative, and we did not reject the null hypotheses, so there's not enough evidence to support the claim. So be careful when you're making that statement. Pause and try. So you should have this hypothesis statement where the claim is on the null. Again, it's a right tail test. Be very careful. You have a test statistic. It is a true statement when you do your test, so we reject the null, which means there's enough evidence to reject the claim. This next example is how to do hypothesis testing when you're giving a list of data. So listed below are the lead concentrations measured in different Ayurveda medicines. Ayurveda is a traditional medical system commonly used in India. The lead concentration listed here are from medicines manufactured in the United States. Use a 0.05 significant level to test the claim that the mean lead concentration for all such medicines is less than 14 UGGs. So here's our list. The first thing we always want to do is identify your hypothesis statement. So in this case, you see that they're asking us to test to see if the medicine is less than 14, which would be our alternative statement. So the complement would be greater than or equal to for our null. We are going to find our critical value using alpha, which is 0.05, and the degree of freedom, and in this case, you have to count the data. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data pieces, and the degree of freedom is 1 less, so we end up getting 9 as the degree of freedom. So we're going to find our critical value, and the critical value is based on the alternative hypothesis statement. So we're going to find our critical value, and we're going to get a negative 1.883. Now, when we have a list, to find your test statistic, you're going to need to enter in that list into the list option in your calculator. So first, enter in the data set into your calculator. To do that, you're going to press Stat, and number 1 should be highlighted, so you're going to hit Enter, and then you're going to enter in your data into your list 1. So you want to make sure that you enter in all the data, and always double check that you entered in the data correctly. Once the list is entered in, to find your test statistic, you're going to have to highlight your data option in this screen. So highlight data, and then you're going to choose your mean, population mean. Now the population mean, again, remember that you're highlighting the data, and make sure that you use the population mean, which is always given in your hypothesis statement. So in this case is 14. Then you're going to choose list 1, which is entered in there normally. If it's not entered in there, you're going to go to your second button, and above the number 1 you see that L1. That's how you would enter it in if it's not showing up already. The frequency stays at 1, so if it's not 1, make sure it's 1. And then you want to choose the right alternative statement. So in this case, we have the less than, so you want to make sure that that statement is highlighted. And then you'll arrow down to calculate, and then you'll get your test statistic. So in this case, our test statistic is going to be a negative 1.444. And then you need to compare. So you're comparing, and you see here, is my test statistic less than my critical value? And it's not, it's false. The test statistic is not less than your critical value. And because it's false, we fail to reject the null hypotheses. And if we fail to reject the null and the claim is on the alternative, there's not enough evidence to support the claim. So again, remember the wording in your statement and the process to take. Pause and try. So for the hypothesis statement, you should have come up with the mean is equal to 60. That is where the claim is on the null, and the alternative is not equal to 60. Your critical values, because it's a two-tailed test, you have 2 critical values, a negative 2.145 and the positive 2.145. Your test statistic would equal 0.530, and when you test to see, because it's positive, you're testing against the positive, and the 0.530 is not greater than 2.145. It's a false statement, therefore you fail to reject the null. And if you fail to reject the null and the claim is on the null, so you can state as a decision at a 5% level significance, there is not enough evidence to reject the claim. So the next hypothesis testing we'll be working with is for proportions. And for proportions, we use the z-test. So to use the z-test for the population proportion, you have to check if the binomial distribution is, so to test the z-test for a population parameter, it must meet this condition. It can be used when a binomial distribution is given such that our sample size times the proportion or percentage is greater than or equal to 5, and the sample size times the percentage of failure is greater than or equal to 5. If it meets this condition, then you can do the z-test population proportion. So the test statistic is the sample proportion, which is going to be that p hat. And the standardized test statistic is your z-value, and it's represented by this formula, where your z is equal to your p-hat minus your proportion percentage divided by the square root of your portion percentage times the percentage of failure, all divided by your sample size. So remember that your sample percentage, if not given, is based on the number of successes divided by your sample size. So the hypothesis testing for proportions, finding the critical value, your z sub alpha or z sub 0 in a proportion p. The first thing you're going to do is identify your level significance. Again, the critical value is based on alpha. So to find the critical value, your z sub alpha, you can use the TI-8384 calculator, or you could choose to look it up with the table. To find the critical value or values, your z sub alpha or the z sub 0, you can use your calculator, the TI-8384, or you can use your table if the hypothesis test is, and we're going to go through the process. I just want to remind you of how to find that z value using the calculator. Again, you go to the second VARS button under distribution, and you're going to choose number 3, which is the inverse norm. And then you're going to put the area. And remember, the area and alpha are the same. Alpha is our area. And then you would press enter. So if you have a left tail test, then alpha is the area that you would enter in. And then you would find your critical value, your z sub alpha. If you have a critical value, a test statistic that is less than your critical value, then it rejects the null hypothesis because that test statistic would fall into the rejected region. If you have a right tail test, in order to find your critical value, you're going to have to use 1 minus alpha. So remember, when it's shaded to the right, you always need to use the area to the left to find the z value. So you have to do 1 minus alpha to get the correct critical value. And then lastly, if it's a two-tailed test, you're going to have to take alpha and divide it by 2 in order to find the correct z value or critical value. So remember, you're going to have both the positive and negative of that value. And if it is true that our test statistic is less than critical value or the test statistic is greater than the critical value, then we would reject the null hypotheses because it would fall into the shaded region. So again, a key note is the test statistic will be found by using your calculators. The critical value is found by finding the z value for alpha, and it's based on alpha. The test statistic is based on the formula for the test statistic. Using the z-test for proportion p, you're going to always identify your hypothesis statement no matter what testing process we're using. You need to know what alpha is. Alpha gives us our critical value. And you're going to find that critical value using alpha. And in the z-test, it's what we just showed you. If it's left tail, it's going to be a negative z value. If it's right tail, 1 minus alpha, and will give us a positive z value. If it's a two-tailed, you need to divide alpha by 2, and then that would be the area you would look up in the calculator. That would be our critical value. The test statistic based on the formula. So we're going to be using the calculator here to find our test statistic. You're going to go to stat. You're going to choose test. Make sure you're choosing the right option. Because we're working with proportion, you want to make sure it's the one proportion z-test. In most calculators, it's number 5. If it's not in number 5, you want to make sure it's the one proportion z-test. Now, if your x value is not given, your sample successes, you would take the sample percentage and multiply it to the sample size. That will give you the number of successes, which is your x value. The next step is if your test statistic is in the rejection region, you would reject the null, otherwise you fail to reject. So you're testing. If you have a left tail test, you're testing, is my test statistic less than my critical value? Right tail test, is my test statistic greater than my critical value? And two tail test, it's one or the other. Then Z is in the rejected region, and you reject the null hypotheses. Once you have that, then you're going to interpret the decision in the context for the original statement. So make sure when you make your first step here, your hypothesis statement, that you have the claim written. And then you're going to make that decision statement based on the testing process. If the claim was on the alternative, you're going to use the word support. So if the claim is on the null hypotheses, make sure in your statement that you use the word reject or fail to reject. If the claim is on the alternative, make sure you use the word support or fail to support. So let's find that test statistic Z in the calculator. So we have this example here. All I'm doing right now is finding your test statistic so you know how to do it in your calculators. A researcher claims that less than 40% U.S. cell phone users have used their phone for online browsing. A sample of 100 adults, 31% say that they use phones for browsing online. And then we have a level of significance, or alpha, of 0.01. And they're giving us the hypothesis statement with the claim on the alternative. So I want to find that test statistic. The test statistic, in order to do this, you're going to need your population proportion or percentage, and in this case it's always going to be given in your alternative statement or in your hypothesis statement. So in this case it's 0.4 or 40%, and then we needed to find our X value. So to find your X value, you're going to take the percentage, the sample percentage, and multiply it to the sample size. And in this case, it's 0.31 times 100, which would give us our X value. Our X value is 31, because you always need the success value. So if the success value, which is your X value, is not given, you're going to need to find it by multiplying it to the percentage of success. So a key note here is that X value cannot be a decimal. It needs to be round. If you don't round it, the calculator will give you an error message. So when you enter in the data, you need to have your population proportion percentage, which will be in the hypothesis statement. You're going to need that X value, and if it's not given, remember to calculate it based on your sample percentage and your sample size. And then make sure you highlight the right tail test, which is given in your hypothesis statement. So in this case, it's less than, and then you'll calculate it and you'll find your test statistic. So our test statistic is that Z value of a negative 1.837 or a negative 1.84 to round. And then it also gives us our p-value. So this is how you find your test statistic. So now we're going to put it all together in an example. We have a research center claims that less than 50% of U.S. adults have access to the internet over a wireless network with a laptop computer. In a random sample of 100 adults, 39 say that they have accessed the internet over a wireless network with a laptop computer. At alpha level of 0.01, is there enough evidence to support the researcher's claim? So the first thing I'm doing is writing my hypothesis statement. And in this case, my statement or my claim is on my alternative statement because it's less than 50%. So that would give me my alternative statement. So the complement would be greater than or equal 50% or 0.50. Make sure you're identifying your claim. Identify alpha, and alpha is given at 0.01. With this information, I can find my critical value. Remember, the critical value is based on alpha. And based on the alternative statement. And because it is a left-tailed test, I'm just going to enter in alpha into the calculator, and I'm going to find my critical value. So my critical value in this example is a negative 2.33. Now I want to find that test statistic. And remember, with finding the test statistic, you need the X value, your success, the number of successes in the trial. And to find that, you use your sample percentage times your sample size. And in this, we end up getting 39 is our X value. And then we're going to plug in all this information and get our test statistic. Standard test statistic Z is equal to a negative 2.2. And now we need to do the comparison. We're checking to see, is our test statistic less than our critical value? And you see in this case, our test statistic is not less than our critical value. It's a false statement, and because it's a false statement, we fail to reject the null hypotheses. So if we fail to reject the null hypotheses and the claim is on the alternative, then there's not enough evidence to support the claim. So it's really important that you use the right wording in your decision and that you know where the claim is in order to make that decision. So let's do another example here. Weaver Research Center claims that 25% of college graduates think a college degree is not worth the cost. You decide to test this claim and ask a random sample of 200 college grads whether they think college is not worth the cost. Of those surveyed, 42 replied yes. At a alpha of 0.10, is there enough evidence to reject the claim? So we want to write the statement, our null and our alternative. So our claim here is on the null hypotheses, where we have the probability equal to 0.25. So the alternative statement is not equal to. Now we're going to find our level significance, which is 0.10, and we're going to find the critical value. The critical value is always based on alpha, and it's a two-tailed test, so we need to divide alpha by 2 in order to find our critical value. So we find our critical value, and again, remember, you're going to have both the positive and negative when you have a two-tailed test. And this critical value, because it's one of those special ones, has 1.645 or a negative 1.645. It goes 3 decimal places. So be careful when you're finding the critical value. There's 2 special ones, and this is one of them. So then we're going to find our test statistic, and in this case, our X value is given. We don't need to find the X value. They told us that 42 said yes. So we have our X value. We don't need to do the calculation. And then we're going to find our test statistic. So our test statistic is a negative 1.31. And I'm testing it against the negative region because it's a negative test statistic, and I'm seeing if it's true. And in this case, it is a false statement. A negative 1.31 is not less than a negative 1.645. So because it's not, it fails, or it's false, it fails to reject the null hypotheses. And because we fail to reject the null hypotheses, there's not enough evidence to reject the claim. So it's important to understand how to write your statements. Pause and try. So in this case, the claim is on the null hypotheses. At least your critical value is a negative 2.33. That test statistic is a negative 2.46. It is a true statement. Our test statistic is less than our critical value, and it's always based on the alternative. Therefore, we reject the null hypotheses. And because the claim is on the null, there is enough evidence to reject the claim. Pause and try. So in this case, our claim is on the null hypotheses. We're looking to see if our percentage is equal to 30%. It's a two-tail test, so our critical values is both the negative and positive 1.96. Our test statistic is 1.85, so we're testing it against the positive critical value, and we see that it's a false statement. Our test statistic is not greater than 1.96, and we fail to reject the null hypotheses. And because the claim is on the null, and because the claim is on the null hypotheses, and we fail to reject the null, there is not enough evidence to reject the claim. Pause and try. So in this example, this is our hypothesis statement where the claim is on the alternative hypothesis statement. Our critical value is 1.28. Our test statistic is a negative 0.20, and it's a false statement. Our test statistic is not greater than our critical value, therefore we fail to reject the null. And because we fail to reject the null, there's not enough evidence to support the claim. So make sure your decision has the right information or the right wording.